Hello, ladies and gentlemen. We're going to do a little Chapter 7 crash course here. I'll do a couple questions from each section that's going to be on your test this week. So, first question is a verify problem. When you're doing verify problems, you want to think of which side looks more complicated. I'd say this side looks more complicated than the secant. The reason you pick the more complicated side is it gives you more things to try. Especially when you get stuck, it's nice to be able to try different things. When I see a problem like this, one strategy you can use is to distribute the cosecant. So I'm going to try that because I have a good feeling about what's going to happen. Now, I'm allowed to do this only because the denominator is a monomial. So we can split it up. And if you look at it, if I worked backwards and I said, oh, these two have a common denominator, so when you add them, tangent plus cotangent would be over cosecant. You're allowed to do this because the denominator is a monomial, a single term. If it's a binomial, this usually isn't very helpful. So I'm only doing that because there's a single term in the denominator. Now what I'm going to do is make everything in terms of sine and cosine. So this is the sine of theta over the cosine of theta. That's tangent over 1 over the sine of theta. And cotangent is cosine over sine. And that's also over 1 over sine. So this looks messy right now, but it's going to clean up nice in a second. This is sine of theta over cosine of theta. And I'm going to now, instead of dividing by 1 over sine, I'm going to multiply by the reciprocal. So that's sine of theta over 1. And I'm going to do the same thing over here. So this is, instead of 1 over sine, it's going to be sine of theta over 1. And let's look and see if there's anything we can clean up. Does anything cancel out these guys? That would be sine squared over cosine. And this is sine times cosine over, oh, cancel those out, and you get cosine of theta over 1. So we're getting close. I think I can see how this is going to end. I'm going to give this guy a cosine so that these guys have a common denominator. And now it's sine squared theta plus cosine squared theta over cosine of theta is the denominator. And hopefully you see it now, because this is a Pythagorean identity. Sine squared plus cosine squared is 1. 1 over cosine theta is the secant of theta. And that's what we were trying to get, so we're done. The last step in a verify problem should always be you saying, hey, look, I did it. You wanted me to prove it was secant? It's secant, because 1 over cosine is secant. Let's try some 7-2. Addition and subtraction properties. We're probably going to need our formulas here, so let's get those handy. These are the formulas I may need. Tangent of 75. So one thing I told my class is that if you have the tangent of 60, that's radical 3, that's fine. The tangent of 30 is radical 3 over 3, and if you can avoid it, because that makes these problems a lot harder. So I'm going to see if I can find two angles that add or subtract to 75 that don't use a multiple, don't use 30. Let's see. How about I do 120 minus 45? That'll do it. That's a 60-degree reference angle. That's what I'm looking for. So the tangent of 120, we're in the second quadrant. So it's negative radical 3, and the tangent of 45 is 1, so that'll be easy. I just got to use the formula. The tangent of A minus B is right here. So I need the tangent of 120 minus the tangent of 45 over 1 plus their product. 1 plus the tangent of 120 times the tangent of 45. Remember, the tangent of 45, if these are both radical 2 over 2, then the tangent of 45 is 1. So the tangent of 120 in the second quadrant, tangent negative, it's negative radical 3 minus the tangent of 45 is 1 over 1 plus negative radical 3, which I'm going to write as 1 minus radical 3. And again, times 1 is just going to still be radical 3. So this is radical 3, this is 1. When you multiply them, you get radical 3. It's negative because, again, tangent of 120 is negative in the second quadrant. Now you have a good looking answer, but it's got a radical in the denominator, so we're going to rationalize it. And the way we do that is we multiply by what's called the conjugate. So you take these two terms, 1 minus radical 3, and you multiply them, but you put a plus sign in the middle. This will clean up very nicely, and that's kind of the point. On the top, I'm going to distribute, so negative radical 3 minus 3 minus 1 minus radical 3. And in the bottom, when you distribute, you get 1 plus radical 3 minus radical 3. Those cancel out. Minus radical 3 times radical 3 is 3. So this equals negative 2 radical 3 minus 4 over negative 2. See how these are like terms? Negative 1 and negative 1. If you have negative 1 radical 3 and you take away another one, you have negative 2 radical 3. And obviously negative 3 minus 1 makes negative 4. Last thing you can do, if you see that these guys all have a negative 2 kind of thing, like, oh, I cross those out. You cannot cross those out. They are connected by addition or subtraction. But you can factor. So I'm going to factor out a negative 2, and that will give you radical 3 plus 2. Because that's negative 2 radical 3 minus 4. And when you do that, now you can cancel out because this is multiplication. And division undoes multiplication. So that is your answer, radical 3 plus 2. I'm going to have to make some room here, so let's get this stuff out of the way and shrink it up. Let's do now a simplified problem that has a property, an addition or subtraction property. So if you tell me the sine of x plus pi over 2, I need to know the property for the sine of a sum. That's right here. So sine times cosine plus cosine times sine. That would then look like the sine of x times the cosine of pi over 2 plus the cosine of x times the sine of pi over 2. So pi over 2 is right here. That's 0, 1. That means the sine is 1. The cosine is 0. So this is the cosine of pi over 2 is 0 times the sine of x plus the sine of pi over 2 is 1 times the cosine of x. Well, 0 times the sine of x, that's 0, and 1 times cosine is the cosine of x. So this simplifies to the cosine of x because of the property. Alright, that's 7-2. Let's try 7-3. If the cosine is negative 5/6 and the tangent is less than 0, first thing I like to do is draw a picture and figure out where I'm at. If cosine is negative, cosine's negative over here somewhere, and if tangent's also negative, remember tangent's positive in the first and the fourth, so tangent's negative, I gotta be in this quadrant because tangent is negative and cosine is negative. So let's just draw a triangle. This is like my helper triangle. It's not on the unit circle. So if I call this x, the tangent of, or the cosine of x, negative 5/6, adjacent hypotenuse. And I can do Pythagorean theorem to figure out the missing side. So 36 minus 25 is 11, so this is radical 11. Once you have that triangle, you can find the sine, you can find the cosine, you can find the tangent, or any of their reciprocals. But I don't ask for any of those. I ask for the sine of 2x. So again, you have to use these properties. The double angle formula is here. The sine of 2x is 2 times the sine times the cosine. So if I want the sine of 2x, that's 2 times the sine of x times the cosine of x. And now I can figure out all of those different things. The sine of x would be opposite over hypotenuse, radical 11 over 6. The cosine of x was given, it's negative 5/6, but you can see it here too, adjacent hypotenuse. Then I multiply the numerators. 2 times 5 is 10, and 6 times 6 is 36. So the sine of 2x is negative 10 radical 10 over 36. I'm going to do pretty much the same thing for the cosine of 2x, but it's a different property. It doesn't matter which one you pick. I just like this one, so I'm going to do that one. 2 cosine squared minus 1. So the cosine of 2x is 2 cosine squared x minus 1. So I'll do 2 times, the cosine is negative 5/6, and when you square it, you're going to get rid of that negative. So 2 times 25 over 36 minus 1, that is 50 over 36, because remember that's 2 over 1, minus 1. But I'm going to write it as 36 over 36, so I get the cosine of 2x is 50 minus 36 is 14 over 36, which reduces to 7 over 18. So the cosine of 2x is 7 over 18. Actually, I should have reduced this one too, so let's go back and fix that. This is 10 over 36, which is 5 over 18. If one of them reduces, the other one probably should. So I didn't catch that, but now we can. The last thing I need is the tangent of 2x, and you can use the formula for tangent. if you want, you can use that formula. But if you have sine and cosine right in front of you, the tangent of 2x has to be the sine of 2x over the cosine of 2x. So what I'm going to do is just use these two answers. So the sine of 2x is negative 5 radical 10 over 18, and the cosine is 7 over 18, but if I copy, change, flip, I get that. And those cancel out, negative 5 radical 10 over 7. So the tangent of 2x is negative 5 radical 10 over 7. You could get there using the formula, but I have a feeling it's probably a lot messier. So that's your best answer right there. 7.4. Find the exact value. Well, if you tell me to find the inverse cosine of a 6 over 11, what a lot of people don't realize is that that's giving you an angle. The inverse cosine takes the ratio of two sides as its input and outputs an angle. So what I've noticed is that some people like to rewrite this to kind of make sense of what it's saying. It's saying that 6 over 11 is the cosine of theta. When you flip these two, when you flip x and y, that's the inverse, and now we've got the inverse, the regular cosine is 6 over 11. The reason that helps you is because now I can say, oh, if cosine is 6 over 11, and I'm doing an inverse cosine problem, so I have to be in the first or, well, cosine, inverse cosine is first or second quadrant. So if cosine is 6 over 11, that's 6, that's not a 6, 6, and that's 11. So I can use Pythagorean theorem to find the missing side. So 11 squared minus 6 squared will give you the y squared. So that's going to be 121 minus 36. 121 minus 36 is y squared. So we're going to do 121 minus 36, and we're going to get 85. So this is the square root of 85. Now if I want to find cotangent, I need to find adjacent over opposite. So 6 over radical 85, but you have to rationalize it. So this is going to be 6 radical 85 over 85. It ain't pretty, but you can check it. So if you have a calculator handy, let's check it. If I do the cotangent, which is 1 over the tangent of the inverse cosine of 6 over 11, I should get the same thing as 6 radical 85 divided by 85. Come on, be 0.65079. Yes, we get it right. Cool. Going back to what I was saying earlier, if you have this memorized, that the tangent of 30 is radical 3 over 3, this problem's a lot easier. Now, it's negative, and when you're doing inverse tangent, you restrict to the right side. So if tangent's negative, that means we're down here somewhere. And since I know that the tangent of 30 is radical 3 over 3, this is 30-degree reference angle. Now, you could write your answer as 330, but that will be marked wrong because inverse tangent has to have the answer between negative 90 degrees and positive 90 degrees. So your best answer here is either negative 30 degrees or negative pi over 6 radians. Either one of those would work for this, but you can't say 300 degrees and you can't say 11 pi over 6. Those would both be marked wrong. The last section is solving. So the first thing you're going to want to do is decide if factoring is necessary. And in this problem, when you see sines and cosines in the same problem, the answer is probably yes. So what I'm going to do is look what these two terms have in common is a cosine. So I'm going to factor out a cosine, and I have 2 sine x minus 1. Now we can use the zero product property to say either of these factors needs to be 0. If cosine of x is 0, I will find a solution, or if 2 sine of x minus 1 is 0, I will also have a solution. And you just need to figure out when that happens. When is cosine 0, and when is 2 sine of x minus 1 0, which will probably, why is that not horizontal? Be horizontal, you stupid, there you go. So, cosine of x is 0. Cosine is 0, cosine is x right here. So that means x is in radians, pi over 2 or 3 pi over 2. So we got that one covered. Now we need to solve this guy, and to do that, I'm going to isolate the sine of x. So the sine of x is 1/2, and that happens when you have a 30-degree reference angle. And since sine is positive in the first and second quadrant, there are still two answers here. That would be pi over 6 and 5 pi over 6. So there's 4 solutions here. 1, 2, 3, 4. This equation has 2 solutions. And when it says solve for the interval from 0 to 2 pi, what you just need to be careful is that all of these answers are between 0 and 2 pi. What I mean is, for this one, you could have said pi over 2 and negative pi over 2, but negative pi over 2 doesn't fit this criteria, so you have to make sure you pick the right coterminal angle, the one that's between 0 and 2 pi. All of these angles are between 0 and 2 pi, so I'm good. The last question has a cosine squared and a cosine to the first, so you should think, oh, this is definitely going to be one where I'm going to have to factor because it's a quadratic trinomial. And most of the time, it helps you to do a substitution. So I do what I call a U substitution. That's a calculus idea. We're just kind of using it to make this problem easier. Because now I can factor. So I'll split the middle here, find numbers that multiply to 4 and add to negative 5. That'd be negative 4 and negative 1. And then I find the GCF, so this is really nothing new. So I have 2u minus 1 and u minus 2. So those are my factors, which means u would either be 1/2 or 2. And that's great. It's nice to know what u is, but that's not what I asked. I want you to solve this equation. So you now need to unsubstitute, and instead of saying u, go back and say that u is really the cosine of x. So if the cosine of x equals 1/2, I can find solutions, or I could find solutions when the cosine of x equals 2, which I'm not going to have a lot of luck there because cosine has to be between negative 1 and 1. So that doesn't provide you any help. But this does. When is the cosine of x 1/2? Well, cosine is positive in the first and second quadrants, or first and fourth quadrants, I mean, when x is positive. So cosine's positive over here. When cosine is 1/2, that means that you're talking about a 60-degree reference angle in either the first or fourth quadrant. So x is between, or x is either pi over 3, or x is not 6 pi over 3, but one less than that, 5 pi over 3. And this problem says find all solutions. When you find all solutions, you need to include all of the coterminal angles. So you need to put a plus 2 pi n there on the end. And we really should say that n is an integer, and you could be fancy here and say something like this, where n is an integer, but we'll probably just say something like n can be positive or negative, but it's got to be a whole number. And then you have all of the coterminal angles for these two, because you could add 2 pi or you could subtract 2 pi from pi over 3, and you will always get a coterminal angle. That's it for 7.1 to 7.5, so good luck on your test.